Hello, this is Mrs. Scarple, and in this video we are going to cover finding the roots or identifying the roots of quadratic functions. The easiest way when it works is to look for x-intercepts. And I look at this parabola and I see that I have intercepts at exactly -3 and at x equals 2. And when we identify roots, we can identify them as x equals a value. They don't need to be written as ordered pairs. So x equals -3, x equals 2 are our roots. Now if I didn't have a graph, another way I could identify my roots is by factoring or using the quadratic formula. Now because I know that these have nice integer roots, I know that this quadratic is going to factor. So I'm going to be looking for what are values or factors of -6 that will combine to give me 1. Well, I know that that could be 1 times 6, one of them being positive, one being negative, or 2 times 3. I know that I need a positive 1 for that middle term. The way that will work is if I have x plus 3 times x minus 2, because a positive 3 minus 2 will give me that positive 1. So this is my factored form. Once I have it factored, then I set each factor equal to 0 and I solve for x. So x plus 3 equals 0. X is going to have to equal -3 in order for that statement to be true. X subtract 2 equals 0. X is going to need to equal a positive 2 in order for that to be true. So I got the same roots as I had from my graph. Because these roots are integers, because these roots are on the x-axis, we can say that these are real roots. Let's take a look at our next one. Again, I have the graph of a quadratic, but I can't quite exactly tell what my x-intercepts are. When I can't tell what my x-intercepts are exactly, that's an indication that this quadratic is not going to factor. There aren't going to be any factors of 7, with one being positive, one being negative, that are going to combine to give me a -2x for my middle term. In that case, I need to use the quadratic formula. And the quadratic formula is x equals opposite of b plus or minus the square root of b squared minus 4 times a times c, and all of that I've just mentioned, including the -b plus or minus, is written over 2a. So now I need to identify the a value and the b value and the c value of my quadratic. My a value is 1. It's the coefficient of the quadratic term. My b value is -2. It's the coefficient of my linear term. And my c value is -7. It's the constant on the end. If you are missing b or c, because c is always the constant, b is always with the x, if you're missing one of them, then you can say that its value is 0. So now let's place these into our quadratic formula. Opposite of b, so opposite of -2 is 2, plus or minus the square root of -2 squared, and I put this in parentheses so that when I enter this in the calculator, it does give me the correct value, minus 4 times 1 times -7, all over 2 times 1. Now I can take that expression, that radicand, that expression underneath the radical sign, and enter it in my calculator all at once. and have it give me the value of 32 all over 2. Now to fully simplify this, we need to simplify our radical, the square root of 32. When you simplify a radical, you want to break it down into a perfect square number times another factor. Perfect squares would be numbers like 1, 4, 9, 16, 25, and so on. They are numbers that there's another number times itself that gives you that number. 16 is a perfect square number because its square root is 4, and it goes into 32 2 times. So I can break up the square root of 32 into the square root of 16 times the square root of 2, which simplifies to 4 times the square root of 2. So I can replace that square root of 32 with 4 square root of 2, and I can write both the 2 and the 4 square root of 2 over 2 to simplify further. And 2 divided by 2 is 1, plus or minus 4 divided by 2 is 2, square root of 2. Now keep in mind, you can only simplify that value in front of the square root with the denominator. You cannot simplify what's inside a square root with the denominator. So our roots are x equals 1 plus 2 square root of 2 and x equals 1 minus 2 square root of 2. And the types of roots that we have are real, but in this case we would also describe them as being irrational. Because they aren't integers, we still have a square root, so we call them irrational. Where before, we could have said real roots, we could have said rational roots, because integers are rational numbers. So let's take a look at our third graph. Here we see that we only have one x-intercept. Now we've talked a little about the fundamental theorem of algebra, and that states that a polynomial of degree n will have n roots. Well, a quadratic is a degree 2 polynomial, so we should have 2 roots. Because I have an x-intercept, I have a fairly good indication that this will factor. So if I look for values of 4, or factors of 4, that I can combine to get a negative 4, that's going to be the 2 and the 2. If they are both negative, they will multiply to give me a positive, and when I add them, they will give me the negative 4. And then if I set each factor equal to 0, we have x equals 2 in both cases. What we say now is that we have a double root. So we have x equals 2 as our root. It is a real, rational root. It is also a double root, meaning that it appears twice as a root. It's also sometimes called a root with multiplicity of 2. And let's take a look at our fourth one, excuse me. This one doesn't have any x-intercepts. I can check to see if it's going to factor, but I can tell you that because it doesn't intersect the x-axis at an integer point, it's not going to factor. So again, we're going to have to use that quadratic formula. Identify the a the b, and the c. So let's plug this into the quadratic formula. X equals, opposite of b is going to be 4, plus or minus the square root of negative 4 squared is our b squared, minus 4 times 1 times 5. Remember, all of that divided by 2 times a, which in this case is 2 times 1, and we have 4 plus or minus the square root of negative 4 over 2. Now, when you have the square root of a negative number, that introduces the imaginary number. So if I'm going to simplify this, I can think of it as 4 over 4, or excuse me, 4 over 2, plus or minus I, square root of 4, over 2. Well, 4 over 2 simplifies to 2, plus or minus, the square root of 4 is 2, so we're going to have 2i over 2. But the 2i over 2 is going to simplify to just I, or 1i. So our roots are x equals 2 plus I and x equals 2 minus I, and we have complex imaginary. 2 plus I is considered a complex number. So these are complex imaginary roots. We say imaginary because they involve an imaginary number. And this will happen anytime you do not have an x-intercept. Your roots are going to be complex. And this concludes the video on finding roots of quadratic functions.